Hey, Jim Bergmann. Welcome to Advanced measureQuick Training. The big push behind using measureQuick is about improving the quality of installations. And I can't say it better than Edwards Deming did. It's quality comes not from inspection, but from improvement of the process itself. And that's really what we're doing with measureQuick is changing the way that you do your work. measureQuick not only improves the process, but it's really the industry's most powerful application-based software for HVAC. It's a diagnostic tool, scan tool, performance and testing for HVAC, and it really leverages a lot of different Bluetooth and Wi-Fi tools from a lot of different manufacturers. The app is process focused, so it's going to walk you through a process. It's going to make sure that you get it completed. It's going to assist you with any problems you find along the way. We're going to document the results. And really, measureQuick's unique in the way that it looks at the system. A lot of guys, they're outside looking at what's going on in the condenser or inside looking at temperature drop of the air handler, but they're not seeing everything at once. And that's a huge advantage to measureQuick and all these Bluetooth streaming tools. It allows for easy sharing. We can actually remote stream data to somebody for support, or we can easily generate a report to share with a customer or a OEM. And it's really a one and done, because once we get that data in, we're going to store it in our cloud for the use by all of the technicians in your company going forward. So how's the process improved? Well, the big thing we're trying to do is reduce or eliminate callbacks. We want to reduce those truck rolls. Every time you're in a truck, you're not making money for the company. Also, we're in a labor shortage in this industry, so we need the ability to get these lower skilled guys up to speed faster. And measureQuick, with the remote data sharing and with the process oriented features we have and the just-in-time education really allows us to leverage that lower skilled labor force. If you're like me and you're highly experienced, it's just going to increase your efficiency on the job. It's going to help dramatically because you're not doing all those calculations by hand. And it really helps with the diagnostics, because even as experienced as I am, I overlook things sometimes. It's elimination of that transcribed readings because we're not fat fingering all that data, and fewer errors, faster service. And really all this is going to lead to increased customer satisfaction. Customers love when you're using technology. They really like getting the reports and knowing that their system's working right. Increased technician satisfaction. When you eliminate those callbacks, you feel better about yourself. When you can figure things out and you're learning more, you feel better about yourself. So this is going to really make your job easier, make it easier for field technical support, and really just give you a more professional look. And it's really about growing a digital asset for your company, right? Because once we get all this data in the cloud, we're able to do our future service so much faster, so much better, and that knowledge base stays with your company. A lot of guys just don't understand that callbacks are obscenely expensive for companies. I picked this picture. These are some friends of mine at Jackson Comfort Systems, and I thought this was a great picture because every white shirt there is supporting a blue shirt in the field, right? So you look at that picture, they're about 50-50 mixed there. And the interesting thing is all the people in the white shirts are overhead cost. In other words, that's the people that it takes to manage the technicians in the field. The technicians and the installers are the only ones really bringing in revenue for the company. So when you look at what a callback actually costs, it's not only just going out there and the time doing the callback, but there's opportunity lost because you could be doing something else. And now we're not getting a new customer with the advertising we had, so we're advertising losses. But the big one is all the admin and the office overhead, wages, vacation, training, payroll taxes, workers' comp, insurance, 401ks, uniforms, recruitment, all those things that cost to run that company are overhead costs. Even your rent, your utilities, your vehicle costs, your tools. So when you start adding all that up, a typical callback costs the company between $450 and $1,000 for each occurrence. I was just on the phone 2 days ago with a company that had a 100% callback rate. Every job they go on, they're going back on. They happen to be a new installation company. They're installing equipment in multifamily homes. So they have a lot of challenges, but think about what that's costing them to actually go out and do that. measureQuick's not just used for HVAC. Obviously, we're also doing work in building performance, Title 24, Energy Star, test and balance. People use our tools for electrical combustion. We have a lot of maintenance customers. So it's really used along the trade, along a lot of different trades. and primarily trades that rely on checklists for as part of their service procedures and processes. If you want to download measureQuick, it's available on both Apple and Google Play, so it works on iOS and Android. We typically recommend iOS just because it's more locked down, and we see fewer frustration, a little bit less frustration, even though it's exactly the same software running on both devices. Also, note we do have a really great Facebook page for measureQuick, and there's a lot of Facebook groups out there if you search for measureQuick that you can participate in. And obviously, we also have a really good YouTube channel that walks you through a lot of the processes and how to use them. When you download measureQuick, you're going to have to go through and you're going to do an initial login. At the bottom there, you see it says "Don't have an account, sign up here." You'll click on that, sign in, and you'll log in going forward using your credentials. And you only have to log in if you log out. Right? If you're working for one of our utility programs through ICF, then you're going to have your own login and permission levels. But users can then be added or managed on the cloud side. So we actually have, if you go to measureQuick.com, we actually have a Virtuoso, which you can log in there, and this is your same login for everything on measureQuick. So you can manage your account, manage Virtuoso, manage your app. It's all the same login for everything. And then we can grant users and move around users within companies if your employees already have a measureQuick account. The home screen is the screen you're going to spend most of your time on, and it's the default screen in measureQuick unless you select the vitals mode as your main screen. But this is probably the most popular screen. And up in the upper left-hand corner, there's a little about, and this is where we're going to check our current versions and permissions. So when you click on that, you'll be able to see your company logo. You'll be able to check your permissions. You'll be able to see what version you're on. So if you look in the center panel there, you can see I'm in internal development. Sometimes we have people working in development or internal development, but primarily you're going to be in production if you're working on measureQuick. And then you can see if you're in any of our ICF programs where they're doing utility things, you'll be able to see which programs you have permissions to work in and et cetera on that. So it's pretty simple to check your permissions on measureQuick. The home screen is just simply where we got our system information. Are out and across the bottom there, if you look, you got in that center there, you sort of have 5 different icons. You got the eye, the sunshine, the house, the electrical, and the cloud, or the not cloud, but outdoor readings. So that's where you're going to get your system information put in, outdoor measurements, indoor measurements, electrical, weather data. Down below that little radio button is a live streaming, so you can live stream your data. The plus button is where we're going to do a snapshot or benchmark or clear trends. And then we have a trending button and results tab down below that, and education. So there's a lot of buttons on here, a lot of navigation, but it's pretty straightforward and pretty simple. And we'll go through all of that as we do this presentation. measureQuick has several different modes. By default, it's going to stay in the last mode you worked in. So if you're primarily doing refrigeration, or you're primarily doing heating, or you're doing a lot of non-invasive testing, it's just going to stay in the mode, whatever the last mode is you used. Air conditioning is probably the most common mode that measureQuick is used in, but it does have a really good heat pump heating mode, a gas furnace mode. NIST is non-invasive system test, and we can do that for cooling or heating. That just means simply checking the charge without connecting your pressure probes. We have a refrigeration right now in beta, and then we're even tying in some in-app testing through Supco TechLink, and I believe through BlueVac also will be in that in-app testing screen now. So you can swap between views on measureQuick once you get measureQuick up. And again, our standard view is the home screen there. But if you tap on the trending button, that'll take you to a trending view. And like right here, you can see what I'm looking at is superheat and subcooling. So I can see I have a TXV that's hunting a little bit. And then I can tap that trending button again, and I can go into our vitals view. And the vitals view is really designed for like a one-page view of measureQuick. So if you get those 6 variables in line, pretty much everything else is going to fall in line as far as the operation of the system goes. And really handy view for new users of measureQuick because you don't have to navigate through a lot of screens to actually get a lot of use out of the product. You're going to need to pair your Bluetooth tools in. And, we hear all the time, what tools do I need? Well, measureQuick supports a variety of tools from a variety of manufacturers. We've reached out to most of the manufacturers of tools in the industry that everyone at least we can think of, and offered to integrate them with measureQuick. If you don't see them on measureQuick, it's because we don't have an agreement with them to integrate, or they didn't want their product integrated with measureQuick. So we don't really have the big thing is when we do it is obviously we're trying to get as what tools we add in, we want to make sure are somewhat popular on there, and it is a driver, but Fieldpiece, Testo, AccuTools, all good brands of tools that we support in measureQuick, along with a lot of others, Energy Conservatory, iManifold, there's a lot of other products in there. But once you add your tools in, it's a sort of a one and done. It's a one-time process. So you'll hit the plus add button on the bottom, and you'll add your tools in. Then you'll go in and activate them, and you'll see there's a button to deactivate or a probe manager. And then pretty much what we have to do is map each probe to what it does. Because measureQuick is a diagnostic tool, it needs to know, what probes on your liquid line, what probes on your suction line, what probes in your return air, what probes in the supply air, all the different probe mappings, so that we can tell the front UI user interface what it needs to do. So you will need to go in and map your probes, and once you get them mapped, it sort of locks them in there, and even if you delete the app and reinstall it, I believe it'll hold most of the mapping for you. Deployment of your probes is absolutely critical, and deployment means where you put your probes in the system. Again, it's a diagnostic app, so garbage in, garbage out, right? So we got to make sure that we're connecting the probes in the right place. So obviously low and high pressure, those are pretty simple for everybody. Suction line, 6 to 10 inches away from the compressor. We're actually measuring total superheat for superheat on the compressor. Liquid line, near the service valve. Discharge line, 6 to 10 inches away from the compressor. Discharge line is sort of optional, but I measure it whenever I can because it's just so important to get a discharge line temperature. It tells us a lot about if the system's flooding or if we're running excessive discharge temperatures and could damage the compressor. Return air, dry bulb and wet bulb, we can measure at the filter grill. Supply air, dry bulb and wet bulb, always put it in the closest supply register, and I'll show you that in a slide going forward here, but it needs to go in the supply. Very, very important. You do not want to drill a hole in the plenum and have the probe within line of sight of the evaporator coil, or it's going to give you a temperature that's lower than the actual air temperature split is, because just like we have radiant heat, we also have radiant cooling, and it'll give that false cold temperature to the probe. Outdoor air temperature, out of line of sight of the sun, so we want to get the air temperature going into the condenser coil. And then electrical is just primarily incoming power to the unit. When I talked about earlier, measureQuick is a system test tool. So we're testing from the filter grill on the right-hand side there, and this is where you can stick the probe in front of the filter grill. We're measuring the return air temperature going in at 74 degrees. Goes across the evaporator coil, through the blower, and then out the first supply. And you can see that probe number 3 on the supply register, it's showing that probe up in the register because we want to make sure that it's seeing the actual temperature of the air and not getting what's called an entrained air temperature. I'll show you on a slide coming up here. But if your capacity is low, you need to look for duct leakage. We see that quite a bit because we are testing from inlet to outlet. So duct leakage is a huge problem when you're leaking in warm air downstream of where we're measuring at the filter grill. And if you really get a high estimated airflow number, check your probe placement. A lot of guys like to compare measureQuick's estimated airflow to like a total external static pressure reading and a fan curve, or maybe a capture hood, or other ways of measuring airflow. And if they don't agree, if you're getting a lot of discrepancy, something's wrong, and it's usually your probe placement that's wrong. We have been to the National Institute of Standards of Testing and tested the airflow calculations against a sharp edge orifice, flow funnel, Wilson flow grid array, a bunch of different methods of measuring airflow, and we're consistently within 1 to 3%. So we know that calculation is very precise, but it's very dependent upon good probe position. And evaluation of any air conditioner is really dependent upon the probe position. When we talk about room entrainment, this is a picture on the left here of the wrong way to put your supply probe. Right? Fieldpiece did a great job and Tesla did a great job with putting magnets on their tools, but that doesn't help us if the probe's in the wrong spot. So you can see here I have 75-degree air coming down from the left, and it's getting entrained by that 55-degree air that's blowing out of the register. In other words, it's going out of the register so fast that it pulls in air behind it. And so we end up with not seeing 55-degree air, but maybe around 60, 65-degree air, because the room air is mixing with the cold air, and now the fieldpiece probe's not getting its true temperature. So on the right there, you can see I have that just spread apart the register vanes just a tiny bit so I could get the probe inside of that. And now I got a really, really good supply air measurement. Now, if you don't have a metal register, right? We hear this periodically. People say, hey, the magnets don't work because I got plastic registers. Well, then use a metal binder, just like a paper binder, and clip it to the register and then stick it on the magnet right on the side of the binding clip. And that'll hold you in the register. And again, this is just a supply register, and you can see that probe's again up inside the ductwork. Watch for short cycling of air at the return, right? You can see here I have a return behind an attic access. Now these aren't exactly the same, thermal image is not the same as the picture, but it brings home the point. Attic accesses leak a lot, and your return pulls from a localized area. So if you have an attic set of stairs that are open or they're leaking, you're going to see much higher return air temperatures than you might see at the thermostat temperature. Like your thermostat might say 74, but your return's reading 79, right? It's a good indication you got hot air coming from somewhere, and that can really, really decrease your system capacity. So they make, attic blankets and things like that. You can get in and seal these attic holes, access holes up with, but watch for that short cycle and return because that will degrade the capacity of the system significantly. So we're at the point now we got our probes deployed. We want to just simply, turn it to cool and turn on the system. And you got to remember, as soon as you turn that air conditioner on, it's not doing any cooling, right? The second it turns on, the temperature split is basically zero, right? And as it runs longer and longer, the temperature split gets to its maximum. Typically, it takes 10 to 15 minutes for an air conditioner to get to its full capacity. So you've got to give it a little bit of time. And measureQuick actually has algorithms that'll tell you when the system's stable. So, we got our app downloaded, got our tools mapped, all that kind of stuff's done. It's a one and done thing. We got our probes deployed where they're going to go, and now we're going to start the system and let it run. So measureQuick is all tied around doing a project, whether it's a utility project or just a general measureQuick AC heating cooling project. It's all about doing a project. And the projects can be assigned like through ServiceTitan or other CRMs. And, they could, if you're working an energy program, you're going to see it's got its own project range, or you could be doing a Blue On refrigerant conversion or Sensi Smart maintenance. But each one of those projects is a different type, and it's got a little bit different of a workflow for it. And the user just clicks on the type of test they want to do, and then they work through that workflow. And that's pretty much all there is to it. So once you enter the workflow you want to enter, now the system's stabilizing, so now's the time to gather the data and input customer information while the system is stabilizing, right? And so, we're going around, we're getting model numbers at this point, serial numbers at this point, checking general condition of things, make sure that look at our condenser to see if it needs cleaning or not, look at our evaporator, look at our filter, blower conditions, ducts. Just as a side note now, you never want to benchmark, and we'll talk about benchmarking later, but benchmarking is like recording a snapshot of an optimized system on a dirty system, because it just won't tell you much about the system. But now's the time we record those current conditions, because what we're doing and think of this maybe more as a service project, but we're doing a test so we can see what's wrong with the system and how it's running. As you go through this thing, we're testing again as is. So maybe the filter's dirty, the condenser's dirty. We could, have a leaking return, leaking attic stairs, undersized duct work, dirty blower, whatever's going on there. And it could have an uninsulated line set. And everything here is going to affect capacity. I mean, when you see a lot of these systems out there, you're going to see a lot of systems that are running far below their rated capacity on there. And that's a huge problem for the HVAC industry. So here's an example of a workflow. So the first thing is we're going to start out with details about the project. And in this case here, a workflow is just like a series of steps required to complete an installation task, a commissioning task, a service task. And these can really be done in any order, but each workflow is custom and it's sort of intended to be followed from top to bottom and left to right, and it follows a process. And if you follow that process, it's going to get you through without too many troubles at all. We do have Premier features, and you'll see that, and this is where you can unlock them. And basically, the reason that we came out with these Premier features is because when you're recording this data, it only would save to your local device. And the concept here is we want to give access to this data about the project, the equipment, the profile, the measurements to everybody in your company, right? Anybody that wants to work on that system. So when we open a project in measureQuick, it's going to be open for 365 days. So if you go out quarterly and do PMs, no extra charge. If you have a callback, no extra charge. If you want to stream data on that job for a little while, no extra charge. But it gives you a project open for the year, unlimited data streaming, a really nice photo documentation section, unlimited projects on that, meaning you can do the heating, you could do the cooling, you could do the heat pump, it doesn't matter. Whatever you need to do, you can do for that year. Lifetime storage of the equipment information and the benchmark. And when we have that benchmark, going forward, it's going to give you way better diagnostics because now we know exactly how that system's supposed to run. It's going to allow for NIST testing, non-invasive system testing going forward, and it's also going to give you those company-branded customizable reports. So a lot of nice features on the Premier side of the product. So let's start with the first section of the workflow. Typically, these are project notes. So these are they can be populated for you by your company, or these could be notes that you put in. Things like don't let the cat out when you're there, or new installation, or whatever you want to say in that section. But this information is being collected and submitted, and it can really dictate what type of testing is required. And this could be pre-populated by the office. As you complete sections of measureQuick, it's gonna change from a red X to a green check mark, right? And it just tells you that in this case, I've got the project information in, the job site information in, the equipment information in, and now I'm ready to go into and make my measurements. So as you're doing your workflow, as you enter and you complete each section, it's going to tell you when you're done with that section. Job site details, when you enter the job site, this is where you're going to just drag and drop to the house or building you're working at. And then you're going to enter in or review your customer information, depending on if you pulled it from a CRM. The address is going to be pre-populated by the app, by the geolocation, so you just want to make sure that's right. And then when you're done, you just hit the submit button. You can hit the green submit bar, or you can hit the check mark at the top. Both will do the same thing. So if you're working in the app, and either one that works for you, you can use. But that pin, you want to drag and drop it and put it on the house that you're working in. Now the next one is really, really important. This is our equipment geolocation. And equipment geolocation means that I'm going to drag and drop this next pin on the piece of equipment I'm working at, right? So this is like assuming you have 2, 3, or 20 pieces of equipment on a job site. I want to mark the exact piece of equipment I'm working on. And that is the pin that's going to be associated with that piece of equipment moving forward. So that is like the pin that you want to make sure you have in the right place, because that's going to tell the tech where the unit's at, and it's also going to tie all that information about that system to that pin location. So each one's going to have a unique geolocation. You can zoom in on the map by pinching and squeezing, to make it go in or out, and then you mark it as close as you can to the equipment location as you go. The next one is, when you're entering in that system information, you want to make sure that you're gathering models and serial numbers, and look closely for things like barcodes. They're all over units, and if you got QR codes, we can scan those too. In fact, if you're working on Goodman equipment, one scan of the QR code will give you the make, model, and serial number of the piece of equipment. So very, very handy when we're trying to make that better and better as we go. But that's going to minimize the amount of typing you got to do, and then also you can take a photograph of the equipment tags to make that go even faster. And then you can always edit. When you scan a barcode, it could be hit or miss. Sometimes, like Lennox, I think, puts the model and the serial number in the same line, so you have to scan it twice. And the first time you delete everything about the model or serial number, and the second time you delete everything about the model number. But it's still faster than inputting it by hand. Now we get into profiling. So we got our job site, right? We got our project notes, we got our job site marked, we got our customer information in, we tagged our equipment, now we're in, and we got a profile of the system. And profiling is, for lack of a better term, just like how we sort of expect it to run, okay? And that's different than benchmarking. When we profile a system, a profile is like I have a 2-ton 13 SEER with a TXV and a target superheat of 7. How would I expect to see that thing run, right? Well, everybody knows, well, okay, it's sort of dependent. What kind of duct system's hooked to it? Is it a good duct system or is it a lousy duct system? Has it got a 10-foot line set or a 150-foot line set? Has it got 0 foot of lift or has it got 50 foot of lift? Each one of those installation variables is going to change the operation of that system. So a benchmark is sort of an initial guess that's going to tell us how that system should operate. It's just an educated guess, and it's going to be refined by benchmarking later. And we can do a heating and cooling profile. So we're going to benchmark the system, so we got a starting point. That's really all this is, and it's probably one of the most important steps, because if you're going to use a diagnostic software, if we're going to do any diagnostics, we need to know what refrigerant's in it. What kind of target airflow are you looking for? What SEER rating is the equipment? What kind of metering device does it have? This is not just for measureQuick, but if you're going to service any kind of equipment, you've got to know this information. Installation information. This you should do if you have the time, but it's not absolutely critical that you do, but it will really help going forward if you got this information, because we use this information in measureQuick to further refine how the equipment's operating. So this is things like line set length, line set location, liquid and suction line diameter, filter sizing. We actually calculate your filter face velocity from this numbers, and we need to know these things so we can further refine how that system should operate. And then going forward, we have this information. If we have to go back out to that system, we know what kind of filters are installed on it, and we just know some critical information about how that system's installed. Electrical information, is just simply what it means. At the very top, you're going to see a electrical section when you go into the electrical information, where you tell it basically, is it single phase or 3-phase? What's your nominal voltage? 200, 208, 240, 115. What's your evaporator fan phase and voltage? What type of evaporator fan do you have? Is it a PSC or an ECM? Do you have an electric strip heat, and what phase is it, and what voltage is it? And all this information is used so we can do electrical diagnostics in measureQuick. Now, once you've got all that information entered, you're going to end up on this screen, which is basically you're in the project, you've got your outdoor readings in, you've got your outdoor and indoor readings streaming in at this point. And literally, we're to the point we're waiting for the system to stabilize. And at this point, we're going to get some, once it is stabilized, we're going to gather our electrical data. So you just tap on the electrical measurements button there on the left versus electrical measurements. And that's going to open up the screen all the way to the right, which is the electrical measurement screen. When you connect your Redfish meter up, and Redfish right now is the only clamp meter that's compatible with measureQuick, you want to set it to the kilowatts mode, kW, and you're going to clamp it around the incoming power wireless and your condenser. And then you're going to put it across the contactor, and it's actually going to measure your power in watts, your voltage, your amperage, and your power factor all at one fell swoop. Now, we don't know whether you're on the evaporator or condenser side, so you just, whatever side you're on, you just hit the capture button, and it's going to lock those electrical readings in. And a lot of times what I'll do is I'll go in the indoor fan, and I'll grab that reading first, because a lot of times you have to, what I usually end up doing is disconnecting the, opening up the switch, the service switch on the unit, or if it's a plug-in type unit, I'll unplug it, and we have what's called a power splitter in there we can plug in. But we'll get the indoor fan reading first, because that typically does not change. Right? Our indoor electrical does not change. And then when we're doing changes like adding or removing charge, or working on the condenser, that's when we're going to see changes in current on the condenser side. But unless we change a filter on the unit, we really won't see too much of a change in our evaporator fan electrical on there. So I grab that first, and I a lot of times I'll watch my condensing unit voltage live. In other words, I just won't hit the capture button, and I'll be able to look at those readings live, and as I make changes, I can actually see an increase or decrease of the SEER of the unit. You can always clear those out and take another set of electrical measurements if you need to. Now, we talked about stabilization, and stabilization or steady state means conditions that are no longer changing. So the system will not operate as it's engineered until it reaches a state of equilibrium or stabilization. All right. Well, how does measureQuick determine this? Well, it's looking at the liquid line temperature for TXV and the suction line temperature for a fixed orifice and temperature split of the supply and return air and some other variables. And here you can see I'm in a trending mode, but you can see how things are shifting. And you can see measureQuick is at the top in this upper corner. You see that little squiggly line that's orange. That's telling us the system is not stable. And these are just some screenshots of trending here. But what I want to show you is if you look at all three of those and you look at the last one, you can see that superheat is definitely hunting, right? Now, even though it's hunting, the system is stable, because that is a repeating oscillation, right? It's just going up and down and up and down. And over time, that's really not changing. It's stable. It's not a change that is driving the unit one way or another. It's an oscillation, which is different than trending upwards or trending downwards. In the case of that hunting, it's doing the same trend over and over again. So measureQuick will actually determine that that's a stable system. Watch your vitals. If you haven't used measureQuick before, vitals mode is one of the best modes to get started with. And this is going to allow you to sort of select the type of metering device you have, your nominal airflow, and then again, if these 6 readings are in range, everything else is pretty well going to be dialed in the background. And so what this is really looking at is, when you're looking at superheater and subcooling, is do we have the right amount of refrigerant in the condenser and the right amount in the evaporator? Do we have enough airflow to transfer the heat that we want to transfer? Are the high and low pressures in the right range, right? Remember, your pressures are driving your saturation temperatures. And so those saturation temperatures are what drive the rate of heat transfer. So we got to make sure the evaporator coil's the right temperature. It's cold enough. The condenser's the right temperature. It's not too hot. It's not too cold, so it can transfer at the right range. And then approach temperatures, how close is that liquid temperature to the outdoor air? That tells us a lot about, is the system overcharged, meaning that we're stacking liquid in the condenser, which means we have a really low approach temperature, or is the condenser really dirty and we have a really warm liquid line, meaning the liquid's much warmer than the outdoor air, and that'd be a high approach temperature. And that tells us a lot about that system operation. So that's one of the modes that I spend a lot of time in, just because it gives me a really good snapshot of how things are working without having to flip through a lot of screens. Again, if you've been in this industry, you've had any formal training, you know that heat transfer is a function of time, temperature difference, and turbulence. So we need to make sure that the air is going past the coil at the right rate. Right? This picture of a lighter, the reason I have it there is you guys have all probably lit a lighter and flipped your finger backwards and forwards through the flame, right? And it doesn't get burned at all, right? Well, the lighter's, the flame's 1,000 degrees and your finger's 98 degrees. Well, why doesn't it get burned? Because there's not enough time, right, for that heat to transfer. Now, there's definitely a temperature difference. The lighter's 1,000 degrees, your finger's 98 degrees. So there's a temperature difference to make the heat transfer, but it takes time for heat to transfer. So the rate the air is going past the coil is very, very important. Can't be too fast, can't be too slow, or it's going to affect the heat transfer rate. And then we have to have enough turbulence. The air's got to mix as it goes through there. So, all these things come into factor when we're designing a system and testing a system, and it's really important to think through things as you're using measureQuick and diagnosing system problems. Here's just a typical example of a standard system, probably pretty close to AHRI conditions in this case. It's actually not quite AHR because I'm 80 degrees outdoors, but you can see I have a return air temperature of 75 degrees, right? So we're starting on the left-hand side here. 75 degrees, 50% relative humidity, 67-degree wet bulb. Heat travels from hot to cold, so that warm air, when it goes through the blower and hits that evaporator coil, the heat's going to travel from that warm air into that cold evaporator coil, and now that warm air is going to come out the other side at 55 degrees and maybe a 52-degree wet bulb. And then that heat, that refrigerant in the system's boiling away, and it's going to, we have now this heat-laden vapor that's going to go through the compressor. We're going to raise it in pressure, raise it in temperature, and then we're going to raise the condensing temperature above the outdoor air. So in this case, you can see we're condensing at 100 degrees Fahrenheit. It's 80 degree air entering, so we're 20 degrees above the outdoor air, right? And then we're ejecting that heat outdoors that we absorbed from in the house. And then that liquid's cooled down to, in this case, I think it said 90 degree liquid. So we're 100 degrees outdoors. We have 90 degree liquid. That's 10 degrees of approach, okay? Or excuse me, it's 100 degree liquid and 100 degree saturation temp. We have 90 degree liquid and 80 degrees outdoor air. So it's 10 degrees of approach, right? And then, back to the TXV and back around again. So we're evaluating this. measureQuick's looking at it from a whole system approach. And really important to understand we're going to record these what are called design temperature differences or condensing temp over ambient. It's how much colder is the evaporator than the return air, and how much hotter is the condenser than the outdoor air, right? And those are two variables that are going to really dictate the efficiency of the equipment and also the rate of heat transfer. And so measureQuick is using those numbers to really quantify some of the system performance. But the key thing to understand here is there's nothing magic with measureQuick. It's all just science behind what we do for a living, the science of heating and air conditioning. And you'll learn a ton of things as you start seeing all these things interact and how they all work together. All right, so when it comes to appliance and system performance, here's what you need to know in general. If you get your airflow correct and you get your refrigerant charge correct, the system capacity should be correct. All right, that's all there is to it. If you think about an installation of a system, right? Obviously, we got to have properly sized ductwork on there, and let's just negate that thought for just a minute. But realistically, when you're setting up a piece of equipment, the only two things you can adjust are the airflow and the charge. Yet 7 out of 10 systems, that's where the problems are at. So I want you to think about this for just a minute. If you're not finding charge and airflow problems on 7 out of 10 systems you work on, then you're leaving them with incorrect charge and airflow, and you're leaving money on the table. So very important to get the charge and airflow correct. And performance testing is what we're going to do to assure a customer gets those design BTUs. And honestly, if you think about it, if you've never measured a BTU, then how do you ever know if the system's working correctly? Right? That's pretty important. If you run into problems, you're going to see a red flag in the upper corner of measureQuick, and that's going to tell us that we need to run the diagnostics, which just means tap on that red flag. measureQuick is going to show you faults. The top fault is the most likely problem. In other words, in this case here, there's most likely we have an overcharge of refrigerant. There's 3 symptoms of that. But there's also 3 symptoms that there's a restriction in the liquid line. Restriction in liquid line is a lot less common than an overcharge in the system, but it does have similar some similar characteristics. We also have 2 symptoms of a dirty condenser, and we have low airflow. So as we go through and check things, like if we check our condenser and we visually inspect it and it looks, it's all clean, then we can clear that fault out, right? But then as we get the charge corrected, then all the other faults may completely clear out of the app, because a lot of them are interdependent. Now, probably the airflow being lower than expected is not going to correct itself, but in this case, we're finding a charge and airflow problem. But you got to remember that because there's so many faults that are similar, we have to sort of, it'll always take a technician to figure out what's wrong with measureQuick. If you tap on one of the faults, it's going to tell you what that fault means, what's wrong, and what to do about it. And if you need a little more education on it, there's always the HVAC school icon you can tap, and that'll take you to an educational article about what's wrong. Just-in-time education, we talked about tapping on the faults. In this case here, measureQuick's picking up a potential return air duct leak, right? There's 5 symptoms of that. So it might be things like high suction pressure, high head pressure. It might be things like high superheat on there. But there's 5 symptoms. There's 5 things that are typical when we have a return air duct leak. Low capacity is a typical thing we see with a return air duct leak. So it's going to tell you what that means. And it's going to tell you that the low temperature split indicates there could be a return air duct leak problem. What you need to check, and then how to do that process. Also, we can look at things like our sensible capacity being low. What's that mean? Or how do we clean a condenser? It'll walk you through not only what the fault is, but what's going to happen because of that fault. Then we might have compressor damage because of that fault. These are talking points for your customer. They're educational things for you, so you know what these faults mean and you know how to correct them. Look for low-hanging fruit. And when I say this, I mean our industry is rampant with problems that if you correct them will save your customers a lot of money and generate your company a lot of revenue. These are win-win for both of you because you're making money fixing the fault and the customers getting the problem fixed and getting more comfort and getting lower utility bills. Duct leakage, one of the biggest pieces of low-hanging fruit out there. Return duct leakage pulls in hot air from attics, can be a heck of a mess. Fan speeds being set wrong is another. It's easy fix, but people don't set them. They're left at the factory defaults. Highly restricted filters, right? Or not enough filters is another big problem in the industry. Refrigerant charge being off, condensers being dirty, air bypassing the filters. When you start seeing traps getting plugged all the time, that's typically because air is getting bypassed around the filter and dirt's building up on the coil. Dirty evaporator coils, high static pressures, your trap, you're leaking air backwards up the trap when you have a draw-through trap. Maybe you need a start assist on there. But there's a lot of low-hanging fruit, and obviously when we find that, we want to make those authorized repairs. Once we get the system fixed, charge is right, airflow is right, duct leakage is eliminated, we want to optimize the operation. And optimization means it's running exactly the way the manufacturer intended to based upon the installation. So we got it working as good as it can work. Typically, what you really want to focus on is your sensible capacity and make sure that you're doing at least 95% of your sensible capacity. And if you are, that is likely as well as that unit could run. Now, in this case here, I want you to see our actual capacity is only 80% of the normalized. And, well, what does that mean? Well, notice down below sensible, we're doing only 13.2% of our latent load. Now, here's what's interesting. When you look at a system like this is a 1.5 ton system. Part of the cooling is dedicated to cooling the air, and part of the cooling is dedicated to dehumidification. Usually it's 75 to 25. 75% to cooling, 25% to dehumidification. If there's no humidity to remove, that latent load or that latent capacity goes unused. The sensible capacity should always be there, right? Whether we're dehumidifying or not. And if we're not getting good sensible capacity, that tells us there's something seriously wrong with the unit. If we're not getting latent capacity, it can be one of two things. There's no latent load to remove, or our fan speed is set way too high, and we're just not dehumidifying. And then this is a common problem. Like I said, make sure that airflow is in the right range. If it's a 2-ton system, set it up for 400 CFM per ton if that's what it requires in your market, or 350 if you live in Florida. But high airflow is also going to affect your dehumidification. But here's the other thing you got to remember. Low airflow, which plagues most systems out there, will convert your sensible cooling to latent cooling. So just because you're doing 100% of your actual cooling doesn't mean you're doing the right type of cooling. We always want to make sure that we're watching that sensible and making sure that we haven't converted our air conditioning unit into a dehumidifier. In other words, if you slow the airflow down, you're gonna transition your sensible cooling over to latent cooling, and you're gonna do excessive amounts of dehumidification. And if you don't have sensible cooling, you'll never satisfy the thermostat. All right, it's really important. Once we get that system optimized, we're going to benchmark it. And when we click on the benchmark, what that's going to do, it's going to line up all the targets. This is what everybody in your company is going to use going forward. So you don't want to benchmark a poorly operating system. This is when we get it optimized, we benchmark it. And then other technicians coming out in the future will pull that benchmark down from the cloud so they know how that unit was operating when you left it. Right? So this is really important that we get that benchmark right. Benchmarking now captures the personality of the equipment. Remember before we said we did a profile. Profile is how it would typically operate. Benchmarking captures a personality or its installation variable. So it captures the impact of the ductwork that's attached to it. It captures the impact of the fan speed you picked. It captures the impact of the charge that you have. It captures the impact of the line set length. It captures the impact of the filtering system you have. But what it does when we benchmark that system, we want to assure we're getting that rated capacity, we got the proper latent sensible split, and it's going to normalize all those measurements for the installation. And this is going to allow us to do non-invasive system testing moving forward. And that's probably one of the coolest things we can do with measureQuick. So we got all those measurements stable. We benchmarked the system. Now all we do is we save that data. And once you hit save data, it's going to, on the middle slide there, you can see it's going to pop up that the measurements have been saved. And you can click on view and you can generate the report. Now, if it comes up system unstable, that means you should really wait before you take the snapshot because it's not stable and you're not going to get an ideal reading for your report. Once that is pulled up to view, now you can review the environmental conditions or the performance or any diagnostics, any photo documentation you might have. And then, you can check that if you want to, or you can just go to hit share. And once you hit share, it's going to generate the measureQuick report. So it's going to show you the geolocation, where you're at, what tools were used to make those measurements. It's going to give you all the information about your system performance. It's going to show you what the weather was during the testing. It's going to date and time stamp it. It's going to give you the equipment information, stability of the system, and a lot more. So this is what the output is that we really are wanting at the end of the day with measureQuick is the measureQuick report. Well, how do you interpret this report? Okay, first of all, the system needs to be stable. All right, if you have an unstable system, there's not a lot you can tell about that. Because the system, if you started it up right away, again, it's not going to be outputting its maximum cooling until it's stable. So the key things that I look at the condenser power factor. Condenser power factor 0.95 or above is typically good. That tells us that our capacitor is good on our condenser. I look at my static pressure in my indoor measurements. I look at my total external static pressure. I want to see that about 0.7 or lower. We talk about, total external static pressure is typically rated at 0.5, but at about 0.7 is where things start to go haywire. So there's a little bit of cushion in there, but once you go above 0.7, your static pressure is a little bit too high. It's going to cause excessive fan watt draw or excessive energy usage. On the air handler power factor, if you have a PSC motor, 0.95 or higher. If you have an ECM, it could be as low as 0.65, nothing to worry about. ECM motors run lower power factors, and that's completely normal. But on a permanent split capacitor motor, that power factor tells us if the voltage and the current are in unity. In other words, they're lined up. That's what the capacitor does, is it corrects that lead or lag on the system. Then down on the energy efficiency side, I'm looking at my fan efficiency. I want to see, is that fan efficacy or watts per CFM, is it below 0.58? That tells me if my fan is operating efficiently. I want to look at my EER, and I want to make sure that that's at a reasonable range. And I want to look at my sensible efficiency and make sure, again, that is at 95% or higher. So you can see in this example here, I'm at 82.4%. So I have low sensible capacity. My fan efficacy is high, 0.61, which means I have a low CFM per watts. I probably have an airflow problem with this system. In fact, I do, because it's 1.5 tons, and I'm only measuring 358 CFM. So definitely an airflow issue that's causing low capacity of the system. This is a system in duress. This is how I test in and show the homeowner, Mrs. Jones, we ran a scan in your system. Here's what I'm showing is wrong. And then we correct those problems, and we could get that right back up to full capacity of the system. So most of you guys for your entire career have been going out and hooking up gauges to every system that you work on, right? But I want you to think about this for just a second. How often should the gauges be installed on a system after it's commissioned? Right? And think about this as your refrigerator at home for a minute. If you're on your home refrigerator and it's not cooling, I imagine the last thing you're going to do is run out and get some piercing valves and tap into your sealed system and see what the refrigerant pressure is before you do things like clean the condenser or make sure something's not blocking the evaporator or making sure nobody left open their freezer door, right? It's basic stuff. The last thing we want to do is check charge in a sealed system. So the only time that the gauges should be installed are 3 times during the life. When the system is commissioned, initially getting it set up, when the system's disposed of, when we're doing that final recovery, or when our design conditions no longer hold true. And this means the design conditions that we measured at the benchmark. And we can do all this with non-invasive system testing. But if we're going to check the charge without gauges, you've got to think clean. You got to make sure that we have clean filters, clean blowers, clean condenser, right? And we got to get good measurements of indoor and outdoor temperatures. We're going to just simply verify based off those drivers, is our liquid line and our suction line the correct temperature for the current load we have, right? It's literally just calculation of superheat and subcooling backwards. So we're, instead of measuring the superheat and subcooling, now we're using the superheat and subcooling that we measured at the installation to determine if the liquid and the suction line are the right temperatures. And then we can also verify capacity. So this is a screenshot of a non-invasive system test. And you will get needles on your display, but notice they're blue now. And those blue needles are showing you what the pressure would be if you hook the gauges up, okay? And so it's just for 2 reasons. Number one, so you have an idea where it should be, and so your customer can see that you're using gauges, you're still measuring variables on the system. Now, in this case here, you can see down at the bottom, the superheat and the subcooling are targets now. These are the targets from the benchmark when we benchmarked that system. And now the suction and the liquid line are the 2 temperatures that we're calculating to make sure things are in range. And as long as those 2 are in range, then our capacity should be fine. Sensible, latent, total capacity, everything should be working right. And we can literally make the entire measureQuick report, just like we did before. The only difference is we're calculating what the pressures are now instead of measuring the pressures. So really quite slick way to do the testing. There are a couple cool quick tests in measureQuick. We can do our evacuation with the Blue Vac app. We do have, just as a sidebar before I show you the first quick test, multi-circuit on the way. Right now you can do multiple supply and return air sensors, and they'll be average. So you can do up to 4 supply air sensors and 4 return air probes. And those will be average to show you like the average capacity of the system. So if you want to get like delivered capacity, it's a really good way to do that. You can just map in multiple supplies and multiple returns. Temperature compensated pressure test. This is one of the quick tests. And this allows us to use nitrogen as a test gas. And it basically uses the ideal gas law to determine if the system is leaking. And it automatically calculates a pass or fail. And then the results of this test are added to your report. Now, here's the key thing. Obviously, if we measure a suction line temperature, let's say in this case 60 degrees, and we have a low pressure 173.6, right? And it runs for 715 seconds in this case, and my start temperature is still 60.5. I expect to see my nitrogen change slightly in pressure because my temperature changed slightly. So this is always looking at, because it's a sealed system, right? If the temperature goes up, or the temperature goes down, the pressure will go up or the pressure will go down. If the pressure stays the same and the temperature changes, you will get a fail, right? And what this is indicating is like you left your nitrogen bottle connected to the system and the temperature dropped and your nitrogen regulator just fed and took the pressure back up to whatever it was supposed to be, right? So it's always, it's sort of an anti-gaming feature, but this is the way a pressure test should be done. And this is how, like if you were getting a pressure test done on a chart recorder, is exactly what they do. They'd be watching temperature, watching pressure. They'd expect to see them tracking each other. And then we can calculate what the final pressure would be based upon the ambient temperature. So if your test fails, typically it's because you didn't leave enough time for things to stabilize, especially if the pressure didn't drop. And make sure your nitrogen bottle is disconnected, and then make sure that you let it stabilize long enough. And if you have to rerun the test, you can just reset it and rerun it. Duct leakage. Duct leakage accounts for one of the highest energy losses in the system, and measureQuick just uses mixed air formulas to calculate approximate leakage. And then we normalize those to 25 pascals, which is the same basic pressure that a duct blaster uses. And then measureQuick also accounts for the thermal gains in the duct system. So basically it shows you your capacity losses and the estimated capacity losses due to duct leakage, right? So you can have two things that as far as duct losses go: air leaking into the duct, or just simple heat gain because we don't have good insulation on the duct. And measureQuick accounts for both using the mixed air formulas to do that. The way that works is you basically put a mixed air probe, one on each side of the blower. So you can see in the middle where the blower wheel's at, I got a ×2 mixed air. So I'd want one probe on each side of the blower, one probe at the filter grill. I can measure the temperature of the attic. I don't have to leave a probe necessarily attached in the attic, so I can hand input that if I wanted to. Then one at the supply air. And basically what measureQuick's going to do is it's going to use all these measurements to determine how much duct leakage we have in the system. In this case here, this is actually a real one we did. We had 200 CFM of attic air leaking in, and that was equating to a 33% cooling loss, right? So this is a real quick, easy test to screen for air duct leakage, and probably one of my favorite tests in measureQuick. All right, so the next part of the video will be over Sensi Predict, and I'm going to stop it here, and we'll pick this up on Sensi on the next go-round.